Hey, year one, this is 4D, guys. We're going to talk about using the gradient, aka slope, as a unit rate. So now we're going to be talking about comparing two things. In this particular problem, or intro here, it's talking about euros to dollars or dollars to euros. So actually, rates can go both ways. So if you think of slope or gradient, it's rise over the run. And if it's rise over the run, then I can think of it in this particular graph here as US dollars, so US dollars to the euro. And so the rate would be, so if I had let's go with their problem, 37.45. So that's 37.45 is the point. Well, that really means from here to here and up, right? So this is 37 and 45. That means I have $45 US A dollars to 37, we'll put PB, well, that's the wrong pounds, right? British pounds, we'll say. So $45 to 37 British pounds. I could write that the other way, as in the rate of 37 British pounds to 45 US dollars. Those are rates. And in our problems, you're going to have different rates when you have different problems. If you look in the investigation on the bottom of this particular page, which I don't have up, I do believe it's talking about biking and talking about the idea that you're putting together some dollars per kilometer, pounds per kilometer. Well, the unit rate is pounds, dollars, right? Pounds, I guess, US pounds per kilometer done. So you could pay more money for more kilometers, or more kilometers means more money. Things like that. And so what we have here is some examples I'd like to go through. Sean and Nicole walk every day without taking any breaks during the walks. Sean walks 4 kilometers per hour and Nicole walks 9 kilometers in 2 hours. So they started filling in the table. They want you to complete it. Well, Sean is 4 per hour, so that's 8 and 12. Great. Now the question is, okay, if Nicole, and it's constant, so if Nicole can go 9 kilometers in 2 hours, in 1 hour would be half the time, that'd be 4.5. So that means it's 4.5. So 4.5 times 3 is what? 4 times 3 is 12, plus 1.5, 13.5 kilometers. Okay? It says graph the lines representing Sean and Nicole's daily walks on a pair of axes, where x is the number of hours and y is the distance covered. Okay, determine the gradient of each. Well, technically, let's talk about part 3 before we even do part 2. In part 3, it says find the gradient. Well, guys, we have the slope formula, or the gradient formula. So I technically can choose to use the points 2, 8, and through 6. Ooh, my bad. My bad. Do you guys recognize that I made a mistake for that last line? The last line is not 3, it's 6. So 6 times 4 is 24. And 6 times 4.5. So 6 times 4 is 24 plus 3, 27. Okay, so now we got the right numbers. If I go back and I want to use the slope formula, I can use 2, 8, and 6, 24. I can do rise over run. I can do the difference in the y's over the difference in the x's. So technically, I could do 24 minus 8 over 6 minus 2, 16 over 4, which is 4. And what does that represent? That represents 4 kilometers per hour. That's how fast. It's her speed. Or his speed in this case, that's Sean. And you can do the same thing for Nicole. Now, if I go to the answers that they have, as you can see here, they graphed both graphs. Okay, they filled in the table, they have it here. And you can see that the blue line, which would be representing Nicole, is actually steeper. She actually, if you do the work or using the graph by going up and over for both of them, it doesn't matter, you find out that she has a 4.5 kilometers per hour versus Sean has 4 kilometers per hour. So he has a steeper gradient, which means over time he will go further in the same amount of time. These are things we already know. And if we do the same thing for the bottom one, it says complete, on one Sunday, Nicole gives Sean a head start of 1.5 kilometers. So that's why at 1 hour, Sean has already walked 5.5. Notice that Nicole's still is the same at 2.9. They want you to fill in the chart. And then draw the lines representing Sean and Nicole's walk over the pair of the axes. So the same as before. Things are going to be slightly different because Sean had a head start, which means at time 0, he didn't start at 0, he starts at 1.5. So we're going to make this go a little bit quicker. And then it says determine the number of hours it will take for Nicole to catch up to Sean. So obviously, if we go to our graphs now and we fill in our chart, so we got this chart filled in for Sean and for Nicole. And we look at the graph, and the graphs now change. Up here, Nicole started at 0, Sean started at 1.5. Sean, at some point, goes from the top of the graph to the bottom of the graph. And so you can see that at 3 hours, and even in our chart, 3 hours represents the same exact number. At 3 hours, Nicole will catch up to Sean, and at any time after that, she will surpass him in the distance that they will walk. It's because the y values are the same. And so that's what we have to do today, and we're going to talk about. And so here's your homework. I got the 1, 2, and 4 up here, part of 3. The next slide has 3. You have to go back to the other slide to get the other half of 3. And 5, there is one more part of 5. So make sure you're pausing the video to finish off that. Have a great day, guys.